Ladies and gentlemen, hello and welcome to the next session of our Automotive Design It Day. The topic of this session is why 48-volt systems are ideal for future vehicles. My name is Alexander Nebel. I am Field Application Engineer in Europe and I will moderate this webinar today. We are very pleased that you find the time to join our webinar. Presenter today is Mawad Magdesi, our Field Application Engineer in Western Europe. Before we start our presentation, I have some information for you. The expected duration of today's presentation is 25 to 30 minutes, followed by a Q&A session. Take notes if you wish, but also know that we will publish the presentation as well as a recording of this presentation within a few days. In an effort to have the most optimal environment for everyone involved, attendees will be muted during the webinar. But for sure, we invite you to ask us questions. You can address your questions at any time during the webinar with the Q&A function of the Zoom session. Please, if possible, note also the slide number to which your question is related. We will answer your questions during the Q&A session. If you run out of time, you can also submit questions to the presenters directly or online with the link go.chemet.com/did-contact. With this information, I hand over to Mawad. Hello, Mawad. Thank you for your time today. And you can directly start your presentation.
Hello, Alex. Good morning, everyone. And thank you for your introduction. As you have mentioned, my name is Mawad Magdesi, and I have been with Chemet since 2018, September 2018. And I have joined the team as a field application engineer to provide the technical support to our customers in the west of Europe. Here is the agenda of my today's speech. So I will, after introducing or describing the context of the 48-volt systems, I will briefly describe the operating principle of the 48-volt inverters that are used in the mild hybrid electrical vehicles. I will show then their electric circuit diagram with the different solution that we can provide from our portfolio for the different stages of the 48-volt system. We will focus our presentation on the DC capacitors that we can provide from our portfolio, and also we will focus on the EMI input filter. And finally, conclusions and takeaway. So the context of the 48-volt systems is, of course, the e-mobility. And according to some studies, the vehicle CO2 emission are representing more than 10% of the total CO2 generated by humans, more than 8% of the total petrol consumption, and causing more than 200,000 early deaths per year in the US. In order to overcome this issue, or at least to reduce its impact, the electrification of vehicles have been introduced as a step forward towards moving to a more fuel efficient and more environmentally friendly alternative. An example of these friendly alternative solutions are the battery electric vehicles, the BEVs, or what we call the hybrid electrical vehicles, the HEVs. However, the main drawback of these solutions remain the cost compared to the conventional internal combustion engine vehicles. And to understand better this cost difference, we will see or go deeper in the cost distribution between the conventional internal combustion engine vehicles and the hybrid and electrical vehicles. And we see that the main difference when comparing these two technologies, so here in the blue line, we see the internal combustion engine vehicle, the conventional one, compared to the battery and hybrid electrical vehicles. And we see that the main difference is driven by two main factors. The first factor is the cost of the high voltage battery, and the second factor is the rearrangement of the powertrain due to its electrification. Another important factor or point that we can highlight here from this diagram is that we see that is only by 2025 that the EVs or the HEVs will cost the same as internal combustion engine vehicles. So in order not to wait until this date to start using electrical vehicles and to start reducing the CO2 emission, the 48 volt batteries vehicles have been introduced mainly to overcome this issue. So the low cost of the 48 volt battery and the rearrangement of the power train that is really minimal compared to the conventional internal combustion engine will make the difference with the high voltage batteries. Why is this solution so attractive? As we have mentioned, it is really a very good solution in terms of compromise between the CO2 reduction, the electrification level, and the cost of the solution compared with the high voltage battery solution. And in this case, each manufacturer can use or can adapt their vehicles and start this CO2 emission reduction. Here is the electric circuit diagram of the 48 volt systems, where we see the 48 volt battery that is supplying the auxiliary 48 volt systems like the e-compressor, the engine water pump, the engine cooling, the electrical power steering. And also we have a DC-DC converter that converts the 48 volts towards 12 volts and supply all equipments on board that have a lower power than 600 watt. When it comes to the powertrain, here we see that we will be having an EMI input filter, the DC link, the inverter, the inductive motor, and then we will have the combustion engine. We can see also the BMS, which will make the connection between the battery and the vehicles. But what are the different solutions that we can provide from our portfolio? This is shown here in the slide, where we see for each stage of the power, the 48 volt system, what are the series and passive component that we recommend for each function. So we see the solution that we can provide for the BMS, for the DC-DC converter, for the EMI, for the DC link, for the inverter, and also for the inductive motor. But today, due to the limited time, we will only focus our presentation on the solution that we can propose for the EMI filter and for the DC link. And mainly, we will present the series that we are showing here. But for any further assistance, for any solution or series that you need a support with, please reach to your regional FAEs and sales, and we will provide the support needed. Why we will focus on the DC link? The DC link for this kind of applications is really playing an important function since we have a low voltage, so we are operating at 48 volt, but in the same time we have a high powers. We have powers going from 15 kilowatt up to 30 kilowatt, which will lead to a high RMS current that will be flowing in the DC link capacitors. Also, since the electrical machine used inside the 48 volt system will be operating in a different modes, so e-boost mode or recuperation mode. So all these operating modes will lead to a different current flowing inside the DC link capacitors. So choosing the right capacitors technology and the number of capacitors is really critical for this function. At the same time, the capacitance must have a high capacitance value to reduce the ripple voltage that may be induced at the DC bus voltage. At the same time, oversizing a capacitance will be affecting the overall weight and volume of the inverter, and that's why choosing the right capacitance value will be also critical. From our studies and researches on this topic, we know that our best technology to fulfill this function would be with our electrolytic capacitors, and more specifically with our axials and radial series. We have a lot of designing project with this series, and this is due to their special design. We will see it in the next slide, but here we are showing an overview of the different series that we will have. When we talk about automotive series, they are shown here in blue and gray cases. So these are the different series that we can provide, offering each one of them a different capacitance, temperature, or rated voltage. And what makes this design so special and well suited to this application, it is mainly related to three factors. The first factor is related to the internal design of its cathode. So we have an extended cathode foil, which is connected to the bottom of the capacitors, which will enhance its thermal resistance and increase their current capabilities. We will have on the top side a connection that will be pushed from the top side, which will also increase its current capabilities since the thermal resistance is enhanced. And the third factor is related to the groove that we will apply at the end of the production line, which will enhance its mechanical capabilities. However, today we see a big trend moving forward with the 48-volt inverters to get higher power, and this is coming from the fact that we are moving from the mild hybrid to the hybrid mode. That means, in this case, the vehicle may be able or would be able to operate in a full electric mode. And in this case, we need to provide a solution that will follow this trend. To follow this trend, we have been developing internally at Kemet 3 new series that provide higher power or higher capabilities that will follow this trend. So today we will present these three series: the ultra high CV axial series, the hybrid axials, and the hybrid V-chip SMD series. So the hybrid, the ultra high CV series that we have launched recently are here and presented. So we have two main series, the PEG and the PH 227. So the PG is for the axial and the PH for the radial crown. The second series is the PEG and PH 228, and this series is rated up to 150 degrees. And from its name, you can notice that the capacitance design will be enhanced in order to reach higher capacitance values and the same volumes compared to the previous designs. Typical applications is really the 48-volt inverters, and you can notice that we recommend the use of this series for the DC-link function, but also for the input filtering, EMI. So basically, our customers will use the same capacitance, but one of them will be dedicated for the EMI filtering. This slide, we are comparing the capabilities that will be enhanced with this new series compared to the previous one. And we are showing here the same, so for the same rated voltage, same case size, we will have the double of capacitance at the same volume, while keeping the same ESR and current capabilities, which is really a very nice enhancement in these capabilities, and that will allow to reach higher power or reduce the total oversize of the equipment. So in these slides, we are comparing the new series compared to the previous series and to our best competitor in the market. And today with this series, we will have the best average volumetric capacitance and average volumetric ripple current that will be existing in the market for the 63 volt. The second solution that we can provide here for this function is the hybrid. And just a few words about this technology and compared to the other technology existing and what are the advantages. So here in this slide, on the left side of the screen, we see the architecture of a a typical aluminum electrolytic capacitor with the wet electrolyte. So we have the anode on the left and the cathode foil on the right side, and in between we have the wet electrolyte making the electrical connection with the cathode foil. So these capacitors are well known in the market and well used. However, their main drawbacks would be the ESR values. And this is due to the conductive electric conductivity of the electrolyte, which is low compared to other technologies, and will lead also to failure mechanism related to the dry out of the electrolyte inside. So to overcome this issue, the solid polymer technologies were introduced. So to replace the wet electrolyte with a solid conductive polymer that will enhance drastically the conductivity of the cathode and enhance the ESR value. However, one of the main drawbacks of this polymer technology is the leakage current. So this is related really to the technology, and we know that the leakage current will be higher compared to the wet electrolyte technologies. And this is what is limiting maybe some customers to select this series. So to overcome these issues, the hybrid aluminum technologies were designed and developed, and it's a sort of combination of both advantages coming from the wet electrolyte and the solid polymer. So we will have the good electric conductivity coming from the polymer technology, and we will have the low leakage capability coming from the wet electrolyte. And we will have, in addition, the excellent self-healing capabilities. So with this hybrid technology, we have developed two main families, the Axials Radial Crown and the SMD or V-chip series. The enhancement, as we have mentioned, with the hybrid would be related to the ESR, and this is what we are showing here in this curves with our actual hybrid series, 125 degrees, 370 microfarad, 63 volt. When comparing the same case size, same capacitance, same rated voltage, but the technology inside is the only difference. And here we see that using the actual hybrid series will improve drastically the ESR value. And also we see that the ESR would be very stable on the full range of operating temperature. So when we have this enhancement on ESR, this will be translated on better current capabilities. And this is what we see here on the curve, showing the ripple current capabilities, comparing the actual hybrid with the actual wet electrolyte. So again, the same capacitance, same case size, same rated voltage. The difference would be really on the current capabilities. So once we have this enhancement in terms of current, we will be able to reduce the total number of capacitors used for a function. Here is the data sheet of our actual hybrid capacitors, and we have developed four references, one at 40 volt DC and three at 63 volt DC. And here you can see more information on the part number and the current capabilities for different ambient temperature and configuration. So it depends if there is a heat sink or it's airflow, and the current, of course, will not be the same. Today, we have not yet included our life estimation low or estimated lifetime in our online website for the lifetime calculation, but we provide this data in our data sheet, and this is an extract of what we provide in the data sheet. You will get the lifetime estimated depending on the ripple current and the ambient temperature. But of course, we make a lot of analysis based on the mission profile. If you send us your mission profile, we make the analysis and we will let you know what would be the best configuration in terms of capacitance value and the number of capacitors to be used. So if we take the example of for a mild hybrid electrical vehicle, 11 kilowatt, and this is an example that we have made internally, we have selected for emission profile the use of 5 axle with the standard wet electrolyte technology, 560 microfarad 63 volt in 18 by 35, and this is the number that was needed to fulfill the required function. But when now we have made again the exercise with the hybrid technology, we found that if we keep the same needed performance, we can reduce the total number from 5 down to 3 and get the same function fulfilled. Another exercise was to, if we want to increase the power, let's say if we keep the same number of components with the hybrid, we will increase the power by 45%. Another solution that we are seeing, we have developed, and we are seeing a big trend in the market today. It's whether the SMD hybrid or the actual series that are selected for this function. And here we are presenting our hybrid series, which was also released recently, the A780 series. We have today only 2 values, the 56 and 100 microfarads 63 volts, and can be designed with a standard configuration or with enhanced configuration for from a mechanical point of view. So we have this plastic plate that will enhance the mechanical vibration up to 30 G. But of course, this will not be the only part numbers that we will develop. Here we are showing our roadmap in terms of capacitance values and rated voltage that we will be developed in the next quarters and months. So when it comes to the EMI filter, of course, this is also a big function or an important function for the powertrain. And it depends here if the customers are designing themselves the EMI filter or they are getting the filter already designed. But we are able to provide solution for this EMI filter from the capacitive point of view and also from the magnetic point of view. And of course, when it comes to the magnetic point of view, here it makes more sense to design ferrite cores on bus bars directly, since we have a huge current going through the line current. And to overcome any possibility of saturating the magnetic materials, one turn will be sufficient to fulfill the function. When it comes to the X and Y capacitors, here, of course, we have mentioned that the actual capacitors or the electrolytic capacitor can also be used for the EMI filter, but at the same time, we have some solution to provide from other technologies like the film technology. And here in the slide, we are showing the potential solution that we had also designed with our customers. And we have the 3 main series are the RSB, the R66, and the R60. And you can notice that these series are all designed with the PET dielectric, which has the facility to be very thin compared to the other dielectrics that we have with the film, and make them more suited and more capacitive efficient compared to the other technologies. So these are the main technologies from the film and family that can be used for the EMI filter. For the magnetic part, the way that we operate today is that we get the specification from our customers, because the MC issues are very specific to each of each customer, and depend on several factors. So we work on specification, and we make simulation, and we provide solution. It's interesting to note that at KMET we have our own magnetic materials, so we can have the possibility to enhance and optimize their functions for each of the application. So we have internally different materials that can be suited to different frequency bandwidths, like the 5HT and 7HT that will be more suited for the AM band range. But if we have more attenuation to be made at higher frequencies for the FM band range, in this case, we will be using the 700L or the M1200L. So we will adapt our material that must be used in your equipment to fulfill the required function. What are the solutions that we can provide? So of course it depends on the filter is really specific to a customer and application, and we can provide differential mode, common mode, or dual mode choke. And the difference would be on how we are connecting the ferrite core on the bus bar. If it's for differential mode, it will be only on one side of the bus bar. If it's a common mode, we will be having the ferrite covering both bus bar, the positive and negative. And the dual mode, in this case, we will have this additional ferrite core that will be providing the differential mode in addition to the common mode. So of course, for this kind of solution, we will be adapting to the specification. We don't have a standard EMI course for this function, and we will provide solution on specific request. So once we have the specification, we make simulation and we make some recommendation if some changes must to be done. And here are some pictures showing what kind of solution we can provide. So this is a differential mode, a common mode, and here it is the dual mode. So as a conclusion and takeaway, so as we have showed you today, KMET has solution for the different MHEV 48 volt stages. We can offer the different technologies that can fulfill the different functions. And today, to reach higher power or increased power density, we see that to reach this, we need to use the ultra high CV capacitors or the hybrid technology. When it comes to EMI filter, we showed our film capacitors, our actual series that can fulfill for the capacitive filtering, and for the EMI ferrite bus bar. In this case, it would be a customized solution. KMET makes its own ferrite material and can adapt the material type depending on the requirement, and we can adapt also the shape to the customer application. And with this, I'm open to questions.
Yes, hello, Mawad. Thank you for your presentation. It was very interesting. Also for me, something new I heard. For the moment, I can see that there are not many questions, actually 0, which seems like everything you said was clear. So we are still open for questions, but to all attendees, if you want to ask us, you have still the possibility to contact us directly or use the link go.kemet.com/did-contact. This gives you the possibility to answer all of your questions also afterwards. And with this, if there are still no more questions, I want to say thank you, Mawad, for presenting today. And to all attendees, I hope you have still interest in our still coming presentations. And if you missed one, you can have also the videos later on. So, and then this is all. Mawad, thank you and nice day.
Thank you. Bye-bye.
Bye.